Okay, so once again, welcome back to our lecture video discussion. So for today is we will be discussing all about resistors in series and parallel. So we will be discussing separately how to get the equivalent resistance or the total resistance if the resistors are in series, and also we will also be getting the equivalent or the total resistance if the resistors are in parallel. Okay, so let's start with the resistors in series. So we have here on this figure, we have three resistors, R1, R2, and R3 from point A to point B. So from point A to point X, we have the first resistor R1. From point X to point Y, we have R2 or our second resistor. And from point Y to point B is our R3 or our third resistor. Now here, if the resistors are in series, so this is what a series connection look like. So if the resistors are in series, the current I, so si current daw kuno, must be the same in all of them or in all of these three resistors, meaning the current is not used up as it passes through a circuit. So from point A to point B, kung pila ang iyang amount sa current starting from point A pag-abot sa point B, it must be the same. So dili makulangan or dili makuhaan ang current from point A to point B or as it passes through these three resistors. So again, the current is the same in all of the three resistors or in all of them, but the potential differences across each resistor need not be the same. So kung si current is the same from point A to point B, now the potential difference is not the same from point A to point B. So the potential difference across the entire combination is the sum of these individual potential differences. So what do we mean by that? Okay, so by applying Ohm's law to each resistor, di ba Ohm's law, if we can still recall, Ohm's law is V is equal to I times R. Okay, so if we want to get the potential difference of each resistor, okay, from point A to point B, we will be getting the sum of the individual potential differences. So, getting the individual nga potential differences, so from point A to point X, so we have VAX is equal to I times R1. And then, from point X to point Y, we have V sub XY, sorry, XY, we have I times R2. And then, from point Y to point B is V sub YB is equal to I times R3. So, we have now the individual potential differences of each resistor. So, again, dimension na the potential difference across the entire combination is the sum of these individual potential differences. Okay. So, let's have it here on the next one. So, from point A to point B, kibali ang sum or ang total. So, again, I will be writing this here. So, VAX is equal to I times R1. We have VXY is equal to I times R2. And then VYB is equal to I times R3. So, if you want to get the potential difference from point A to point B, VAB is the sum of the individual potential differences. So we have VAX plus VXY plus VYB. So let's substitute their corresponding values. So we have I times R1 plus I times R2 plus I times R3. So this is now our VAB. Now notice here na di ba ang common out of these three resistors is the current. So we can factor out current. So we have I times, we have R1 plus R2 plus, R3. This is R3. Okay, so now, dividing both sides with I, what will happen now? We have VAB over I is equal to, ang nasa right side sa itong equation is the sum, R1, R2, R1 plus R2 plus R3. Now, take note that V over I, according to Ohm's law, diba si Ohm's law is V is equal to I times R. So, V over I is our R, or in this case is our equivalent or total resistance. So, si VAB over I is our R equivalent or our R total is equal to R1 plus R2 plus R3. So, to get the equivalent or the total resistance of these three resistors from point A to point B is we just need to get the sum of their individual resistances. So, sa resistors in series, we have here the equivalent resistance of any number of resistors. So, let's say for example, we have more than 3 or pila pa nakabok as long as they are in a series connection is equal to the sum of their individual resistances. So, in this case, in this figure, since we have only 3 resistors, so to get the equivalent or the total resistance is we just need to add their individual resistances. So, we have R1 plus R2 plus R3. So, that is how we would solve for the equivalent or the total resistance if the resistors are connected in a series nga connection. Okay, now how about in parallel? Or what will happen now if the resistors are in parallel? So again, we have here in this figure, this is what we mean by resistors in parallel or nakaparallel na siya from point A to point B. Now, if the resistors are in parallel, di ba kung sa series, the current is the same, but the potential difference is not the same. So, pag abot sa resistors in parallel, the current through each resistor need not be the same. So, dili na siya the same ang current through each resistor. But the potential difference between the terminals of each resistor must be the same and equal to VAB. Okay, so baliktad siya sa resistors in series. Diba? So, ang current now is not the same from point A to point B, but the potential difference must be the same and must be equal to VAB or the potential difference from point A to point B. Now, let's call the currents in the three resistors as I1, I2, and I3. So, the current along I or passing through R1 is I1. So, I1. Sa R2, we have I2. And sa R3, we have I3. Okay. So, again now, balik ta from Ohm's law. Diba, Ohm's law? Ohm's law is V is equal to I times R. So, solving for the current, okay, dili man the same ang current sa each resistor, so we need to get the current of this individual nga resistor. So, I is equal to V over R. So, solving for the individual currents, so si I1 is equal to VAB over R1. Then si I2 is VAB divided by R2. And our I3 is equal to VAB over R3. So, muna siya ang mga currents nato, individual currents of each resistor. So, now, in general, so since the current is different through each resistor, now, the total current from point A to point B must be equal to the sum of the currents of each of this resistor. So, kwaon na to ang sum of this individual na currents sa kada resistor. Okay, so we have here I is equal to I1 plus I2 plus I3. So substituting the values of each of these currents, si I1 is VAB over R1 plus I2 is VAB over R2 plus I3 is VAB over R3. Okay. So notice again here the common variable on the right side of the equation is C, potential difference. Kaya the same man ang atong potential difference from point A to point B. So we can factor out our VAB or the potential difference. So VAB times, so we have now 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. Okay, so now we can divide both sides with VAB. So what will happen if ato i-divide both sides of the equation with VAB, it becomes I over VAB is now equal to, ang mabilin sa right side's equation, we have 1 over R1 plus 1 over R2 plus 1 over R sub 3. Okay, so if you want to get the total or the equivalent resistance of these three resistors na nakaparallel, take note na, diba, Ohm's law is V is equal to IR. So si I over V is equivalent to, dili siya si R equivalent, but it is the reciprocal 1 over R. So si 1 over R is I over V. Kaya kung si R, si resistance lang is V over I. So when we say reciprocal, the numerator becomes the denominator and the denominator becomes the numerator. So since I over V man ang ato adre, so kabaliktaran siya sa ato ang resistance na equation from Ohm's law. So that's why we have 1 over R. So we have 1 over R equivalent is equal to 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. So this is how we would, or this is the equation to solve for the equivalent resistance if the resistors are in parallel. So again, if you have more than 3 resistors, so you can just add the reciprocal of the equivalent resistance of each resistor. So for resistors in parallel, we have here for any number of resistors in parallel, the reciprocal of the equivalent resistance, which is 1 over R equivalent, is equal to the sum of the reciprocals. So we have here 1 over R1 plus 1 over R2 plus 1 over R3 of their individual resistances. So let's say for example, if ang ato ang 1 over R equivalent ng value is 2 over 10 ohms, so meaning if you want to get the equivalent resistance, R equivalent, kung na to ang reciprocal ni 2 over 10, which is now 10 over 2 ohms, or 10 over 2 or 10 divided by 2 is just 5 ohms. So ang atong final answer is not 2 over 10 but the R equivalent, not si 1 over R equivalent. So R equivalent is equal to 5 ohms. So that is how you would get the equivalent resistance. Kaya ang kaning formula is the reciprocal pa man siya. So kung na po ni mo ang reciprocal niya para makuha nato ang value ni R equivalent or ni equivalent resistance. Okay, so I hope you get the formulas on how to solve for the equivalent resistance if the resistors are in series and if the resistors are in parallel. Okay, so now let's proceed to Kirchhoffs rules or Kirchhoffs. Some of there are some pronunciations. We have Kirchhoffs, we have Kirchhoffs. So I will just be using Kirchhoffs. So Kirchhoffs rules or Kirchhoffs laws. Okay. So before we start, let's have some definition of terms. So we will be using these terms more often in this topic. So we have the first one is what we call the junction. So junction is a point where three or more conductors meet. So we have examples here on the figure A and figure B. So we have two figures. So nakabutang diri, nakalabel diri nga we have point A, B, C, and D for letter A sa ta. So si letter C is not a junction. Point D is not a junction. Only point A and point B are junctions. So gidefine si junction nga a point where three or more conductors meet. So meaning dira magtagbo. So si C, wala may katagbo si C nga other conductors. So only si point A and point B. So meaning point A and point B are the junctions of this circuit. Now for letter B, how about letter B? Unsa may mga junctions na to ani? So wala naka-label kung asa si junction or asa si dili junction. Now here, notice again, a point where three or more conductors meet. So in figure B, ang ato ang junctions are point A, B, C, and D. So mag-meet man ni sila kani nga mga conductors on these points, whereas si point F and point E are not a junction. So dili siya junction si F and E, only A, B, C, and D. So that is how you would determine kung junction ba na siya nga point or not. So again, from the definition, it is a point where three or more conductors meet. Now, also we have this what we call the loop. So loop is any closed conducting path. Okay, so unsa na to pagkahibalo kung pila ka buok loop. So closed conducting path kuno siya. So balik ta sa figure A. So as you can see, naka-label na, we have three loops. So the first loop is the whole circuit itself. So from here to here, this is loop 1 or the first loop. The second loop is, we have here loop 2. This is a closed conducting path. So this is also a loop. And also loop 3 is on the right side. So we have for letter A, for figure A, we have three loops. Okay, we have three closed conducting path man. Okay, now for figure B, notice here we have 4. Naka-indicate the 4 ka loops. So again, the first loop is the entire circuit. Loop 1, this is loop 1. Now for loop 2, this one right here is also a closed conducting path. So we can consider this one as our loop or loop 2. And then for the third loop, we have this one. And we have fourth loop on below. So, for figure B, naatay upat ka buok loop. So, as long as you see any closed conducting path, we can have a loop here. So, as long as, again, naka-close ang ato ang path, closed conducting path, we can consider it as a loop. So, those are the two terms that we will be timan-an nato because we will be using that on this topic. Okay, so now let's proceed to Kirchhoffs junction rule. So kani si Kirchhoffs junction rule, we can also call it as Kirchhoffs current law or KCL for short. So KCL na lang para mas dali. So unsa man ni si Kirchhoffs junction rule? So si Kirchhoffs junction rule or si KCL states that the algebraic sum of the currents into any junction is 0. So we have here the formula. The sum of all of the currents into any junction is equal to 0. So we have here a figure, again with letter A and letter B, for the junction rule. So this point is our junction. So natay current nga padulong sa atong junction. So on the padulong sa right side, we also have another current padulong po sa atong junction from the right side to the junction. So pag abot sa junction, this is what happened. So the current leaving a junction is equal to the current entering it. So we have I1 plus I2. So pag abot sa junction, si I1 o si I2 is the sum. Pag abot na, total na. Total ni I1 o I2. Pag abot sa junction, pag naog niya or ang direction sa current after is going downwards, and ang ihaana da yung total current is the sum of I1 and I2 nga padulong sa atong junction. So we can also have it, we can have our analogy same sa water pipe. So the flow rate of water leaving the pipe is equal to the flow rate entering it. So kung unsay or kung pila ang amount sa water or pila ang volume sa water nga pasulod, so this, we consider this one here as our junction. So kung pila, again, ang amount sa water nga pasulod gikan sa left nga pipe o sa right nga pipe, pag abot diri sa center, so we only have isa na lang ka pipe ang pagawas. So ang volume nga pasulod is just equal to pila ang amount sa or pila ang volume sa water nga ning sulod. Okay. So that is Kirchhoffs junction rule. So again, the sum or the algebraic sum of the currents into any junction is equal to 0. Whereas si Kirchhoffs loop rule, or also known as Kirchhoffs voltage law or KVL. So kung si junction rule is current law or KCL, Kirchhoff's current law, si Kirchhoff's loop rule is also known as KVL or Kirchhoff's voltage law. So si loop rule states that the algebraic sum of the potential differences in any loop, including those associated with EMFs and those of resistive elements, must equal to 0. So ang atong formula is the sum of all the potential differences must be equal to 0. So mo nang gitawag siya Kirchhoff's voltage law. Whereas si junction rule or current law is the sum of all current into any junction is equal to 0. So those are the two rules or the two laws ni Kirchhoffs. So now let's look at the sign conventions for the loop rule before we proceed in having our example using the Kirchhoff's rules. Okay, so we have here for letter A, these are the sign conventions for EMFs. So, if ang travel sa or ang direction sa travel nato is from negative to positive, then ang ato ang EMF is a positive EMF. Whereas if from positive to negative, ang ato ang EMF is negative. Now that is for the EMFs. Now how about for the resistors? So for the resistors, we have here, as you can see on the figure. Now, if ang travel is opposite sa direction sa current, let's say ang direction sa tong current is going to the left. So if ang travel nato is, or ang direction sa tong travel is opposite sa direction sa current, then ang ato ang sign convention for the resistor is a positive IR. Whereas kung the same direction sa ato ang current, we have a negative nga IR. Okay, so those are the sign conventions for the EMFs as well as for the resistor. So we will be using this one kaning ato ang i-discuss karon sa ato ang example nga ato ang i-solve. Okay. So now we have here an example. So let's draw a circuit. So let's change the color. So we have here, we have a battery, then we have a resistor, and then, so let's draw it first. Okay. And then, so in this circuit, we have 7 resistors, and then we have 2 batteries. So let's label the following resistors, or their values. Let's give them values as well as the voltage source or our batteries. So for the resistors, let's have them as, or let's have them all as 1 ohm. So ato ni siyang ang equivalent ni resistors or tanang resistors nga naa diri nga circuit are all 1 ohm. Okay. So let's label them all. And then how about the battery? So let's have here kaning sa left side nato nga source is we have it as 2 volts, and then kaning sa right side nato nga voltage source is 10 volts. Okay. So mo ni ang ato ang setup sa ato ang circuit. Okay. So now ang ato ang goal is to solve for the current flowing or the current passing through each resistor. So as you can see again, we have 7 resistors. So kwaon nato ang current nga nagpass through sa kada resistor. So we have 7 currents pot based on our source, which is again on the left side we have 2 volts, and then on the right side we have 10 volts. Okay. So in this example, we will be using the mesh current method. So unsa man ning mesh current method? So the mesh current method is a network analysis technique where a mesh, or we also call it as the loop, mesh or loop current directions are assigned arbitrarily. And then we will be using Kirchhoffs voltage law, or the KVL, and Ohm's law. So we will apply that systematically to solve for an unknown current or voltages. So in this case, ang unknown nato ani, or ang pangitaon nato is the, or are the current flowing through or passing through each of these 1 ohm nga resistor. So ang kaning mesh current method is quite similar to the branch current method pod. However, it does not use the Kirchhoffs current law, or KCL. And also, it is usually able to solve a circuit with fewer unknown variables and fewer simultaneous equations. So, kung sa branch current method man good, is we will be having 7 equations with 7 unknowns. Kaya again, we are solving for the 7 currents of each of these resistors. So, kaning si mesh current method is mas gamay ang unknown nga variables, and also mas gamay pud ang equations. Okay. So, what is the step 1? So, na naman tay mga values atong resistors and ato ang sources. The step 1 is to identify and label the current loops. So, kaning sa mesh current method, or ang first step sa mesh current method is identifying and labeling the current loops within the circuit. So, to do this, we must find at least 1 loop current passing through every component in the circuit. So, let's change colors. So, in the given circuit, natay tulo ka loops nga ma-form. So, ang first nga loop will be the loop, this one. We'll have it like this. So, this is our loop 1. Ang atong second loop is this one. And then, our third loop is this one. Okay, so we have 3 loops. So, ang pinaka-strange nga part aning mesh current method is envisioning circulating currents in each of the loops. So, kani mangud siya nga method gets its name from the idea of these currents meshing together between loops. Okay. So, naman tay na ato nang na identify kung asa nga mga loop. Now, the next step is to label the voltage drop polarity. So, ato ang labelan ang mga polarities niya para mahibalaan nato ang direction, ang sign conventions niya. Okay, so we have here in our 2 voltage na source. So, this is negative, this is positive. And here on the 10 volts, this one is positive, this one is negative. Okay, now how about the resistors? So, now remember that the upstream end of the resistor will always be positive. And also the downstream end of the resistor is negative. So here, in kaning nasa atong taas nga 1 ohm, so this is positive, this is negative, and then this one is positive, this one is negative. Also, this one is positive, negative, positive, negative, positive, negative, positive, negative, and then this one is also positive, negative. Yes. Okay. So, we are done labeling the polarities. So, para mas dali na ito mahibalaan ang ato ang sign nga gamiton. Okay. So, as a note lang, the battery polarities are dictated by their symbol orientations in the diagram, and also it may not agree with the resistor polarities. Okay, so ang atong next step is to apply Kirchhoffs voltage law to each of the loop. So, di ba? Kirchhoffs voltage law is the sum, so KVL is the sum of all the voltage sa loop must be equal to 0. So, we have again 3 loops. Okay? So, di ba? Kung voltage using Ohm's law, di ba, V is equal to IR, or I times the resistance of the resistor. Okay, so the starting point for tracing the voltage drops around each loop is arbitrary. So, the same as the direction nga ato ang gitrace. So, beginning with our first loop, okay? So, let's start at the lower left corner. And then, pa-clockwise ang ato ang direction, also accounting the polarity. So, for the first loop, with our current I1, so, let's label kani siya nga as ato ang I1. So, naatay equation. So, again, di ba, mag-start ta dere. So, we have negative 2. And then, minus, we have our V is equal to IR. So, ang ato ang V is 1 ohm times I1. And then, pag abot na dayon dere, we have, again, minus 1 ohm times, ang atuan na dayong current is not only I1, but again, it is part of I2. So, panaog siya, and then, we have I1, and then minus I2. Okay, si I2 is from negative to positive, si I1 is positive to negative. So, minus I2, and then, minus, we have 1 ohm times I1 is equal to 0. So, if we will simplify this equation, ato i-simplify ha, we have negative 2 minus 1 I1 or I1 minus, we have I1 plus I2 minus 1 I1 or I1 is equal to 0. So, we have negative, natay tulo ka negative I1. So, we have negative 3I1 plus I2. So we will transfer negative 2 to the right side. Para ang nalang sa left side sa itong equation are the currents. So we have, it becomes positive 2. So this will be our equation number 1. Okay, so kani siya. We have negative 3I1 plus I2 is equal to positive 2. So, i-repeat na to ang process for the second loop of the circuit with current, we name it as current I2. So, mag-start ta here. Dire na po ta mag-start. So, we have positive na. Negative to positive, positive. We have 1 ohm times, now in I2 minus I1 minus, so plus positive to negative, so minus 1 ohm I times I2, and then minus 1 ohm, and then on this resistor dili lang kay si I2 lang ang agi, but also naapod si I3. So we have I2 minus I3. Okay, again, I2 is from positive to negative. Si I3 is negative to positive, or on the opposite na direction. And then minus, dali na ta, 1 ohm times I2 is equal to 0. Okay, so ito i-simplify ang atong equation. We have I2 minus I1. So let's have 1 I2 or I2. And then minus I2 minus I2 plus I3. No, this is not. Okay. And then minus I2 is equal to 0. So we have 1 I2 minus I2. So ma-cancel out. So we have isa ka negative I2. No, sorry. We have 3 negative I2s. So, negative 3I2 plus I2 is negative 2I2. So, negative I1 minus 2I2 plus I3 is equal to 0. So, mo ni ang ato ang, di naman ni nato ma-simplify, mo naman ni ang pinaka equation yun. So, this will be our equation 2. Okay, so nanatay 2 equations. So at this point, we now have 2 equations with 3 unknowns. So to be able to solve for the 3 unknown mesh nga currents, so we must have 3 equations. So if we will repeat the process, i-repeat na tong process sa atong third nga loop. So mag-start gihapon ta dere. So let's have it right here. So we have 1 ohm. And then this one is I3 minus I2 minus, we have 1 ohm times I3, and then we have minus 10 volts is equal to 0. Okay, so simplifying again this one, we have I3 minus I2 minus I3 minus 10 is equal to 0. So again, I3 minus I3 is ma-cancel out na siya. So ang mabilin is negative I2 minus 10 is equal to 0. So we have, atong i-transpose si negative 10 on the right side. So we have negative I2 is equal to positive 10 na. So I2 is multiplying both sides with negative para ma-positive si I2. So we have negative 10. So this will be our equation 3. So, nanatay 3 equations. So, nanatay value ni I2. Diba? Si I2 is negative 10. Okay. So, ang next step nato is to solve the simultaneous equations for the unknown currents. So, now, with the 3 equations, we can use any of the several methods to mathematically solve for the unknown currents I1 and I3. Kaya namatay value ni I2 which is negative 10. So, ang ato himuon, by substituting I2 which is again equal to negative 10 to I3, I mean equation 1, sorry, para makuha na to si I1. Okay. So, substituting equation 3 to equation 1, we have, diba, negative 3I1 plus I2 is equal to positive 2. So, we have negative 3I1 minus 10 is equal to 2. So, again, i-transpose na to si negative 10 on the left side. So, we have negative 3I1 is equal to 2 plus 10. So, we have 12. So, negative 3I1 is equal to 12. Okay. So, continue lang nato dire. So, dividing both sides with negative 3. So, we have negative 3I1 divided by negative 3. So, we have 12 divided by negative 3. So, cancel out. So, ato ang I1 is equal to 12 divided by 3 is just equal to 4. So, negative 4. So, nanatay value ni I1. Nanatay value ni I2. Now, si I3 na lang dayon. Okay. So, solving for I3, ang ato ang gamiton is si equation 2. So, diba, equation 2, let's have it on the next slide. So, equation 2, diba, is negative I1 minus 2I2 plus I3 is equal to 0. So, diba, si I1 is negative 4. Okay. So, we have negative of negative 4 minus 2 times I2 is negative 10 plus I3 is equal to 0. So, we have 4 plus 20 plus I3 is equal to 0. So, I3 is 4 plus 20 is 24. So, transpose it to the right side. So, it becomes negative 24. So, nanatay value ni I1, I2, and I3. Okay, so now take note that this ang unit ni current are all in amperes. Okay, so nanatay value. Okay, so let's change colors. So, diba si I1 is negative 4 ampere. I2 is negative 10 amperes. And I3 is equal to negative 24 amperes. So, muna ang atong value sa I1, I2, and I3. But, dili pa ni siya mao ang current passing through each of the resistor. Okay, again, we have 7 resistors. So, kaning si I1 is just the current flowing on this loop. Okay. So, again, let's redraw. Ato i-draw balik ang ato ang circuit. So, we have, this is 2 volts. And then, we have this one. Wait. Tapos na i-redraw para sa ato ang next step. Okay, this is 10 volts, and again these are all 1 ohm. Okay, 1 ohm. Okay, so now naata diri, so di ba mo ni ang ato ang direction sa ato ang gi-draw nga loop. So I1, so ang current flowing on this loop is negative 4 amperes. So on the second loop we have negative 10 amperes, and on the third loop we have negative 24 amperes. Okay, so the solution of these negative currents, as you have noticed, na negative ang atong mga currents, I1, I2, and I3. So, that means that ang ato ang initially assumed direction was incorrect. So, in actuality, so baliktad kibali, I1, I2, and I3 flows in the counterclockwise nga direction. So, at a value now of, kung atong i-counterclockwise na, okay, let me erase this one. Ito nang i-change. Okay? Para ma-positive ang ato ang current. So, pa-counterclockwise na ang ang direction. So, paana nakibali ang ato ang direction. Okay? So, ang ato ano dayong current is positive 4 ampere. We have positive 10 amperes and positive 24 amperes. Okay. So, unsa may next step na to? So, ang atong next step na dayon is to calculate the branch currents or the individual currents na on each individual nga resistor. Okay. So, from this mesh currents, we can determine na dayon the branch currents for our circuit. So, we can easily see that the branch current I1, this one, is 24 amperes. Okay. So, kung ato i-draw, ato i-redraw na pod balik ang ato ang current. Okay. Para makita nato. Okay. Okay. So again, this is 2 volts and this is 10 volts. So atong i-label ang mga direction sa atong current. So, let's have it this one, kani siya. Let's have it as our I1. This is our I2. Ito i-label para makuha nato ilang mga values. This will be our I3. And then this is our I4. Let's have it as kanisha as our I5, and then I6, and last is I7. Okay. So as you can see here, si I1 is 24 amperes. So ato ibutang diri ha. I1 is 24 amperes. Okay, diba mo man ni ang since only mesh current I1 passes through the resistor. So, I1 is 24 amperes. So, similarly pod, as you can see here, I3 and I7 are equal to 10 amperes. So, we have I3 is equal to I7 also is equal to 10 amperes. And I5 and I6 are also equal to 4 amperes. So, I5 and I6 are equal to 4 amperes. So, ang wala na lang nato nga value is si I2 and I4. So, muna na siya nga time nga we will apply Kirchhoffs current law at the nodes 1 and 2. So, let's have it as junction 1 and junction 2, or nodes 1 and 2. So, using KCL, let's use another color. Okay. So, using KCL at junction 1 or at node 1, so, we have I1, this one, pasulod sa atong junction, minus I2, and also minus I3. Okay? Ang direction na I3 is away to junction 1. So, is equal to 0. Okay, diba KCL? KCL is the sum of all currents is equal to 0. So, I1 minus I2 minus I3 is equal to 0. So, if we will simplify this one, to get I2, para makuha na to si I2, we have negative I2. Ato i-transpose si I1 and I3 on the right side. So, si I3 becomes positive, I3, and I1 becomes negative. So, I3 minus I1. But take note na si I3, diba I3 is 10 amperes? So, 10 amperes minus I1 is 24 amperes. Ay, sorry. Negative I1 pamanday niya siya. Okay, negative I1 pa niya siya, I2, sorry. So, we will multiply both sides with negative. So, it becomes positive si I2. So, we have negative I3 plus I1 na. Okay, so I2 becomes negative I3 is 10 amperes plus I1 is 24 amperes. So negative 10 plus 24, I2 is equal to pila man? 14 amperes. So nanatoy value ni I2. So let's write I2 here. I2 is 14 amperes. Now how about for at point 2 para makuha nato si I4? Okay. So at junction 2, ang ato ang equation, so this is at junction 1. Now at junction 2, let's use another color para di ta maglibog. At junction 2, ang ato ang equation is pasulod si I3 minus I4, and then I5 is negative since again ang direction is going away sa ato ang junction, is equal to 0. So solving for I4, we have negative I4 is equal to positive I5 minus I3. So again, multiplying both sides with negative para ma-positive si I4, we have I4 is na equal to negative I5 minus I3. So naman tayo value ni I5 and I3, so we can solve for I4. So negative I5 is 4 amperes minus I3 is, no, it becomes positive, sorry, plus 10 amperes. So I4 is negative 4 plus 10 is 6. So 6 amperes. Okay. So, nanatay value, butang natin diri si I4 is equal to 6 amperes. Okay. So, kung ato na siyang i-redraw for the last time, so, kung atong i-redraw ang atong circuit, so, this is, okay, and then, okay. So, this is negative, positive. We have 2 volts. And on the right side, we have positive, negative 10 volts. And then, let's label sa lahi nga color. We have, these are all 1 ohm. 1 ohm. 1 ohm. Okay, 1 ohm. 1 ohm. And 1 ohm. So, let's label their currents na together with their directions. So, kani siya, this is the direction of our current. So, ang current passing through here is 24 amperes. Here is panaog, which is 14 amperes. So, this is our I2. And then, on this resistor, ang atong current passing through here is 10 amperes. Here is 6 amperes. And then we have here is 10 amperes. And then, this resistor right here, ang ato ang value sa atong current is 4 amperes. And also here is 4 amperes. So, muna siya ang mga current flowing or the value of the current flowing through each of the resistor. Okay. So, I think that's it. So, I hope you have learned something from our example. And we'll see you again on our next video discussion. Thank you very much for listening.